sản phẩm được tiêu thụ đến tay người tiêu dùng, sản phẩm đó phải vượt qua rất nhiều công đoạn thiết kế, chế tạo, lắp ráp và kiểm tra, rồi đóng gói, vận chuyển, rồi lắp đặt và dịch vụ sau bán hàng. Mỗi khâu đều có vai trò hết sức quan trọng để có thể làm nên một sản phẩm tốt. Trong đó, một trong những khâu đóng vai trò quyết định sự thành công của sản phẩm, mà nếu như khâu đó không thể đảm bảo và tốt nhất và có thể dẫn đến sự thất bại. Đó chính là khâu sản xuất và chế tạo, khâu ảnh hưởng trực tiếp đến năng suất, chất lượng của sản phẩm. Trong giai đoạn gia công và chế tạo, với sự phát triển của hiện nay của công nghệ, rất nhiều phương pháp gia công chế tạo đã được áp dụng. Đó có thể không nói tới phương pháp gia công cắt gọt vật liệu kim loại và phi kim loại, và cũng không thể không nhắc tới một công cụ rất phổ biến gia công cắt gọt của thứ này, đó chính là máy công cụ này, được biết đến phổ biến nhiều hơn hiện nay với tên gọi là máy CNC. Vậy máy công cụ là gì? Và máy CNC là gì? Chức năng, cấu tạo và vận hành máy như thế nào? Chắc chắn là chúng ta đang rất tò mò muốn biết, phải không? Vậy thì còn chần chừ gì nữa? Cùng nhau tìm hiểu về máy CNC qua môn học này. Mọi thông tin về khóa học các em có thể tham khảo trên website khoa cơ khí Đại học Sư phạm Kỹ thuật Thành phố Hồ Chí Minh, hay ở trong đề cương chi tiết của môn học. Mọi thắc mắc của các em xin gửi về địa chỉ email kienhtr@hcmutE.edu.vn hoặc liên lạc qua số điện thoại 06128993 để được giải đáp. Chúc các bạn đạt được kết quả tốt và học được nhiều điều bổ ích. Ngay sau đây, ta hãy cùng tìm hiểu sơ qua về sự hành CNC nhé.
Simply put, machine tools are power-driven machines of all shapes and sizes, primarily used to create metal parts. Those metal parts might be the steel mold for a plastic automobile headlight. They might be the aluminum supports for a jet airplane body. Or they might be parts to another machine tool. Machine tools have left their legacy, cut, stamped, and shaped into the metal of every imaginable product. Machine tools are, at their core, tools. If you think about a tool like a hand drill, a machine tool takes that drill's process and mechanizes it, and performs it more precisely and more efficiently than a human ever could. The most widely used machine tools today are called machining centers. They perform a host of operations from drilling to milling to boring. A raw block of metal goes in, a finished part comes out. One place where this began was the Cincinnati Screw and Tap Company, founded in 1884 by George Mueller and Fred Holtz. Today, the company they started is one of the world's leading machine tool manufacturers.
What we do here in Cincinnati is we design, manufacture, and assemble all of our machine tools built in the United States. This particular machine is called the U5 because it can operate on 5 sites of a part. And these days our customers, in trying to reduce setup, they want to complete a part in one operation. Hence they want to be able to operate on all 5 sides of the part. Typical customers of this kind of machine tool are tool and die manufacturers. The machine would come in and would actually shape the die, for example, in the shape of a door frame for a car. There are 2 Pentium microprocessors running the computer that runs this computer numerical control machine. The computer directs all the operations of the machine tool. There might be up to 50,000 unique tool points all blended together in one motion. You can store literally hundreds of thousands of data points in a machine like this.
Machine tools don't come cheap. This one starts at close to $1 million, and that price can quickly double as features are added. Also building the machine tool business was R.K. LeBlond, which opened in Cincinnati in 1887 with just a handful of employees. Today, it's the Makino Company, one of the largest machine tool manufacturers in the world. Among other things, its tools make precision parts for the Space Shuttle program.
This is one of the stages of an impeller for the main shuttle engine. What happens is we take 3 of these, stack them together, and together they'll generate about 76,000 horsepower running at 36,000 RPM. This is a turbo pump for the oxygen on the main shuttle engine, and it has the ability to drain a swimming pool, Olympic-sized swimming pool, in 59 seconds.
The part is machined from a solid piece of titanium that can cost as much as $50,000. The machining center cuts it to precise, extremely complex specifications.
It takes about 13 or 14 days straight just to mill this part. So this is probably as difficult as it gets.
While machine tools remain as a legacy of the Industrial Revolution, since the 1960s they have taken on a new level of sophistication, rivaling their initial design. The most dramatic changes have to do with how they are controlled. The earliest machine tools used flywheels to control the position of the tool and the speed at which it cut. Beginning in the early 1950s, those flywheels came under the control of paper tapes and punch cards, used to trigger a precise numeric routine. That routine could be easily repeated. The process was called numeric control. Numeric control was invented in 1947 when John Parsons put a milling machine under the control of an IBM punch card. It spawned a whole new world of machine tools.
The biggest change in machine tools occurred with the introduction of numerical control. That basically made it possible to automate the entire machining operation. Instead of relying on the operator turning hand wheels, the motion of the machine is basically directed by the numbers that are read off a tape and then translated into corresponding motions that will duplicate the shape that the designer had in mind.
Everybody thought this was a great innovation where you had a paper tape that ran through a machine and you put your workpiece on. When machines became more automated, then they would have one man to set the machine up and an operator who simply put the workpiece in and push the buttons to start the machine, take the workpiece out, put another workpiece in, and there the responsibility was on the setup man.
Numeric control systems dramatically improved with the addition of computers in the 1960s.
The training and experience resides in the computer that controls the machine tool. And that's made it possible for the machine tool to do things that were simply impossible when they were operated by hand. We can do things that involve accuracies and shapes that would simply be beyond the capability of the machinist's ability to coordinate eye and hand to turn the wheels that move the workpiece or move the spinning tool against it.
Computer control means more fluid shapes can be made by the machine tools. One reason for the new modern fluidity seen in so many products. Fluidity that first had to be created on a machine tool. Robots have also been added to machine tools to move parts and change tools.
The automatic tool change mechanisms are unique mostly to the machining centers. In the machining centers, they can utilize many tools, from a 40-tool magazine up to 400 and 500 tools in a magazine.
By definition, the cutting edge of a machine tool must be harder than what it is cutting. As metals get harder, machine tools have had to adopt ultra-modern cutting techniques. Many machine tools now use a process called electrical discharge machining, EDM. Powered by electricity, the machines use electrons to vaporize the material instead of cutting it with a tool.
They use the energy of a spark to essentially explode a microscopic bit of material away from the surface. This is microscopic, so it's something you can't see with the eye. But as that heat builds up to a certain point, it's at least as hot as the temperature of the sun, a small bubble of gas forms, and when that bubble of gas explodes, it blows away a microscopic bit of metal from the surface.
Like an electronic bandsaw, a microscopically thin wire charged with electricity cuts metal with a very fine edge. The cut is extremely smooth, eliminating the need for further machining. Some of the most modern machine tools being developed today don't work with metal at all. At Cincinnati Machine tools that are a combination of many different technologies are being used to create a brand new fiber material that's stronger than titanium, yet lighter than aluminum.
Basically, for 100 years, machine tool builders have been creating machines that take raw components such as cast iron, steel, or titanium, and by machining and cutting, we remove metal in order to create a finished part. This is the reverse process where we take the actual material, in this case fiber composite material, and we lay it and place it, building up the finished part for our customer. What I'll show you here is the actual fiber threads, fiber strands that are running through these 32 toes.
Multiple strands allow the fiber to be molded into smooth, fluid shapes. As it is laid down, the fiber is heated for fusing and cut to precise length. Holes are left for windows and other components. The new material is perfect for building lightweight new aircraft.
I think that in the next 10 years, we will still see the computer and communications technologies as the fundamental driver of innovation in the machine tool industry. It has been a driver for the last 20 years. We expect to see that knowledge start to become embodied in the machine tool itself. And it's the computer and the evolution of computer and motion control technology that's allowing that to happen.
From their earliest days in the small shops of London to the modern computer-controlled machining centers of today, machine tools have been at the center of man's industrial evolution. There is little doubt machine tools will continue to shape our future, just as machine tools undeniably shaped our past.